Hello all, welcome to the next subtopic of electrostatics, and in this subtopic we are going to learn about electric dipole moment. Okay, and I want to inform you that this is not in our syllabus, in the revised syllabus of 2020 and 2021. This electric dipole moment has been removed, okay, because of COVID pandemic. Uh, so we will be learning this electric dipole moment as per the entrance point of view only. Okay. So before learning the electric dipole moment, you know the term magnetic dipole moment, or it is called as magnetic dipole moment. What is magnetic dipole moment? If suppose you consider one magnet, there will be a north pole, there will be a south pole. If you consider the pole strength, the north pole strength is plus m. What it is? Plus m. While the south pole strength is minus m. What it is? Minus m. Where m is what? M is called as pole strength. Pole strength. And there is what magnetic field which is starting from north pole and it is ending towards the south pole. This is called as magnetic dipole moment. What it is called as magnetic dipole moment. That is what a magnetic field is there. Also, if you consider the magnetic length of the two poles, see there are two lengths in the magnet. The magnetic length it is given by 2L, while the geometric length is capital L. The distance between the two ends is called as geometric length capital L. While the poles are somewhat inside the magnet. The poles are inside the magnet. Okay, and we say this is what plus M, this is what minus M, and 2L is the magnetic length. You can say 2L is the magnetic length. Then what is magnetic dipole moment? Magnetic dipole moment it is given by capital M. What it is given by capital M? Capital M it is equal to small m into 2L. Capital M it is equal to small m into 2L. So this is the value of magnetic dipole moment. Okay. Now we can say something about electric dipole moment. What is electric dipole moment? Electric dipole moment means, let's suppose that there will be what obviously electric field. Instead of magnetic field, there will be electric field. Now, if you consider the dipole means what? Two poles. Dipole means two poles. So why magnetic dipole? Because magnets have two poles, positive and negative, plus and minus m, right? Plus m, minus m, north pole, south pole. Similarly, if suppose I am talking about charge, one charge is of polarity plus q, another charge is of polarity minus q. So now this is what the strength of the charge. Plus q is the strength of the charge, minus q is the strength of the charge. Similar to that of plus m and minus m. And if I say the distance between this is what 2l, again the distance between this is what 2l, then this will act like a magnet. This will be acting like what? A magnet. Why? Because there will be an electric field instead of magnetic field. Electric field it will be starting from the positive plus q. It will be ending towards the minus q charge like this. There will be what? An electric field, right? So there will be an electric field like the magnet. There will be electric fields. Okay. So this is acting like what? A magnet. Starting from plus q ending towards minus q, that means plus q is acting like a north pole and minus q is acting like a south pole because electric lines of forces are getting inside the minus q and it is getting originated from plus q. So this is called as electric dipole moment. Here magnetic dipole moment was capital M. Electric dipole moment it is given by capital P. Capital P it is called as electric dipole moment and it is equal to what was the for magnet it is M, where M is the magnitude of any one of the polarity. Here magnitude of any one of the polarity is what? Q, and the distance is same 2L. So we say P it is equal to Q into 2L. This is what? This is the formula of electric dipole moment. What is this? This is the formula of electric dipole moment. Now, charge is a scalar quantity, it does not have any direction. So we can say P bar it is equal to Q into 2 into L bar. Okay, so P bar it is equal to Q into 2 into L bar. This is what the vector format of P, and this is the scalar format of P. What is the SI unit of P? Anyone can guess this SI unit? What is the SI unit of charge? It is coulomb. What is the SI unit of length? It is meter. So coulomb meter is the SI unit of electric dipole moment. Coulomb meter is the SI unit of electric dipole moment. So you can pause the video and you can note the things down. So what is called as electric dipole moment? A pair of equal and opposite charges. So pair means what? Pair means there will be two charges. Pair means jodi. A pair of equal and opposite charges. So equal and opposite means what? One is of plus q, another is what? Minus q. Now they are separated by a finite distance. There is a finite distance. There is a known distance, and suppose that distance is what? Equal to 2n. And this is called as electric dipole. This will result into what? Electric dipole. The speed is equal to q into 2l bar. This is what electric dipole moment. Okay. If I say the diagram will be the same thing that we have already understood. This is the diagram. Uh, at position A, there is a charge of minus q. At position B, there is a charge of plus q. Okay, and PQ is called as equatorial axis. PQ is called as equatorial axis. Equatorial axis. While XY is called as principal axis. Principal axis or same axis or only axis. Okay. So principal axis or equatorial axis is about the two axes. The distance between these two is 2L, and we know that this P bar it is equal to Q into 2L bar. This is called as electric dipole moment. Okay. Next we are going to learn is a couple acting on the electric dipole in a uniform field. So if suppose an electric dipole is there, what do you mean by electric dipole? If suppose if this phrase come in front of you, electric dipole. So what is the meaning of this electric dipole? Electric dipole is nothing but the presence of plus q and minus q charge. They are separated by some finite distance. Suppose it is what 2L is the finite distance. So this is called as electric dipole. Now if it is kept in a uniform electric field, if it is kept in a uniform electric field, that means this is what a uniform electric field. This is a uniform electric field E bar. So this is a uniform electric field E bar. So what we are going to get is a couple. Couple means what? Couple means torque. Couple means what? Torque. What do you mean by couple or torque? Two forces of equal two forces of equal magnitude but opposite direction. Two forces of equal magnitude but opposite direction is called as couple. Two forces of equal magnitude but opposite direction separated by some distance. What will be there? Separated by some distance. They should not be acting on a one point only, separated by some distance, finite distance. So two forces of equal magnitude but opposite direction. If suppose this is one point, if you consider this force which is of plus F and this force which is of minus F. So these two forces are equal in magnitude but they are opposite in direction. Okay, plus F and minus F is going to cancel each other and the total force it will be zero. Total force it will be zero. That's why this is written that they should be separated by some finite distance. Okay, so again we will be drawing a diagram of two forces of equal magnitude but opposite in direction. So if you consider a surface like this, This force is acting in this direction, this is plus F, and this force is acting in downward direction, this is what minus F. So these two forces are of equal magnitude but opposite in direction. So what is going to what is the result of this? The result is nothing but the rotation of this table, the rotation of this line. So this line is going to perform rotational motion. So there will be a rotation. That means if suppose there is a word named couple, there is a couple name, or there is what a torque name. So torque or couple, it results into what? Rotation. It results into rotation. So couple acting on electric dipole in a uniform electric field means the electric dipole, that means plus q charge and minus q charge, they are going to rotate if they are present in uniform electric field. Okay, let us see how they will be rotating. So if suppose this is what the couple of forces, this is what minus q charge and this is what plus q charge. They are separated by some finite distance, and that finite distance is 2l. Okay, and they are kept in electric field, uniform electric field. So uniform electric field means electric field is here also. The electric field is same throughout. The electric field is same throughout. If you remember the relation between force and electric field, or the definition of the electric field, the electric field is nothing but force per unit charge. Electric field is nothing but force per unit charge. So that means electric field and force direction are same. So we can say for plus q charge, if I want to calculate force, what I want to get is force. So what force will be equal to force that is equal to q into E. And if suppose this q is positive, so if suppose q is positive, the force will be equal to plus q into E bar. If charge is negative, then this F bar will be equal to minus of q into E bar. So this positive sign indicates that E bar and F bar are in same direction. This negative sign indicates that E bar and F bar are in opposite direction. So this is what plus q charge. So the force acting on the plus q charge will be in the direction of electric field. This will be what this will be in the direction of electric field because they are of same direction. F bar it is equal to plus q E bar. But on the negative side, minus q side, the force it will be like this. This is what a force F bar, which is in this direction, opposite direction. So what we can say that the forces are acting there are equal forces. Both are what F, okay, and they are opposite in direction. They are opposite in direction, and they are separated by some finite distance. And that finite distance is nothing but the perpendicular distance actually. So this much distance, this distance. If this is 2l and this is angle theta, so this much distance will be this much distance will be 2l sine theta. What this will be 2l sine theta. Okay, so the couple acting, it is nothing but the torque, and the torque is equal to force multiplied by perpendicular distance. Force multiplied by perpendicular distance. This is the formula of torque. Okay, so tau bar, I can say tau bar it is equal to F bar cross 2l bar. 2l bar is the perpendicular distance. If you remember the cross product formula, the cross product formula is actually tau it is equal to uh, F AB sin theta. So this is F into 2L sin theta. Okay, so this is what sin theta I have already written this, right? This is what F is there. So what is the formula of F? The value of F is plus QE. Suppose I am writing the magnitude. I am not interested in direction. So Q into E into 2L sin theta. So actually this Q into 2L it is equal to what? P. 2 into Q into 2L it is equal to P, right? Charge multiplied by the distance. We have already understood that is called as electric dipole moment. Electric dipole moment it is called as P. So this is what P E sin theta. is what tau it is equal to P sin theta. Or if suppose you want to again write in the vector format, so tau bar it is equal to P bar cross E bar. Tau bar it is equal to P bar cross E bar. Okay. So again I want to inform you that this is not in our syllabus. We are learning this from entrance point of view. Okay. So you can take a screenshot, you can pause the video, you can complete the things down. So this is actually the diagram where this is what minus q. So minus q electric field it is in this direction. Actually there is a printing mistake, right? So this is the direction of electric field. This is the direction of electric field. So for plus q, the electric field should be in this direction. So actually this should be minus q. So if it is minus q, then this value is what minus. That means it will be opposite to that of E bar. This is called as F bar. While if it is suppose plus q, then the direction of E bar and F bar are same. So this will be again F bar. F bar it is in this direction. The F bar is in opposite direction. If you want to calculate the couple acting, couple is nothing but torque. So the torque is given by actually it is given by P bar cross E bar. So P bar cross E bar can also be written as P E sin theta. So it depends on the value of theta. It depends on the value of theta. The case one is if theta is equal to 0. If theta it is equal to 0 degree. So if theta is equal to 0, how much sin 0 is? Sin 0 is 0. So therefore torque it is equal to, torque will be equal to 0. Torque it is equal to 0. Torque it is equal to 0, that means no couple is acting. No couple is acting. No couple is acting means what? There will be no rotational motion. There will be no rotational motion. If case 2 is what? If theta it is equal to 90 degrees. So sin theta and cos theta, the maximum value is what? 1. So sin 90 is what? Sin 90 is what? 1. So we can say for tau it is equal to P into E. Purely it is P into E. That means this is the maximum value of torque. This is the maximum value of torque. So when we will get the maximum torque? Whenever the 2L value, whatever is the 2L value, this will be exactly perpendicular to the E. So 2L if it is perpendicular to E, then only theta will be equal to 90 degree. Okay, so there we will be getting the maximum torque. And what is going to be the case 3? The case 3 is if theta it is equal to again 180 degree. For 180 degree the sin 180 value is what? 0. So again the torque will be getting minimum torque it is what? 0. So torque minimum will be getting at theta is equal to 0 degree. Torque minimum will be getting for theta is equal to 180 degree, while maximum torque will get for theta is equal to 90 degree. That means if suppose 2L, the 2L is parallel to E bar. 2L is parallel to E bar. Whether it is parallel, then it will be 0 degree. If it is anti-parallel, then it will be 180 degree. So whenever this 2L it is parallel to E bar, we can say that torque acting or couple acting is 0. Whenever this 2L is perpendicular to E bar, we can say that the torque acting is maximum. Okay, so there's nothing but the explanation about the couple acting on the electric field. There's not in our syllabus. We are learning for the entrance point of view. So I request you all to please take a screenshot. Okay, again you can note the things down by pausing the video. So the next topic that we are going to learn is the electric intensity at a point due to electric dipole. So we'll be learning about the axial position, the principal axis position, and the equatorial position. Okay, thank you so much for paying attention. Keep learning.